Limited safety, sustainability and recyclability are key drawbacks of today's lithium-ion battery technology, along with restricted availability of starting materials, e.g. In the search for alternative electrochemical energy storage systems for use in e-mobility and for storing energy from renewable sources, a combination of battery and capacitor is very promising, the hybrid supercapacitor. It can be charged and discharged as quickly as a capacitor and can store. In comparison to the latter, it can be charged and discharged much faster and much more frequently. While a lithium-ion battery achieves a service life of a few thousand cycles, a supercapacitor manages around 1 million charging cycles. System made of carbon and salt water are particularly sustainable, but so far quite unexplored variant of such a hybrid supercapacitor consists of carbon and aqueous sodium iodide electrolyte, with a positive battery electrode and a negative supercapacitor electrode. Researchers at Graz University of Technology have now investigated in more detail how exactly the electrochemical energy storage in this supercapacitor works and what happens in the nanometer-sized pores of the carbon electrode, and have recently published their promising results in the Scientific. The system we are looking at in detail consists of nanoporous carbon electrodes and an aqueous sodium iodide electrolyte, in other words salt water. This makes this system particularly environmentally friendly, cost-effective, incombustible and easy to recycle, explains Christian Prehal. He is the first author of the study and has recently moved from the Institute of Chemistry and Technology of Materials at TU Graz to ETH Zurich. This corrects the previously suspected reaction mechanism and has far-reaching consequences. As Christian Prehal explains, the degree of filling of the nanopores with solid iodine determines how much energy can be stored in the electrode. This enables the energy storage capacity of the iodine-carbon electrodes to reach unexpectedly high values by storing all With targeted improvements, hybrid supercapacitors can now be put to use as a safe, non-flammable, cost-effective and sustainable alternative for stationary storage of electrical energy. This can be an attractive option especially for the storage of energy from photovoltaic cells in private households, for example. New investigation method for electrochemical energy storage systems. The researchers achieved another breakthrough with regard to the investigation methods used. Both methods took place in operando, i.e., live during the charging and discharging of a specially developed electrochemical cell. The results of the work show that operando SAXS is ideally suited to follow structural changes in a supercapacitor or battery on the nanometer scale and directly live during charging and discharging. This new investigation method could therefore be widely used in future in the field of electrochemical energy storage. Story source: materials provided by Graz University of Technology. Original written by Suzanne Eigener. Note: content may be edited for style and length. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.